Okay, so welcome everyone to our first e-seminar. It's quite ironic that today is also the first day of lockdown for many of us. So obviously with the restrictions in place, I've decided to move our seminars online, and Naoki has kindly agreed to present for us. So Naoki is an associate professor at the Faculty of Sports Science at the Nihon Sports Science University. I apologize for my pronunciation. He received his PhD in sports science from the university in 2013. He is an NSCA certified strength and conditioning specialist, weightlifting coach, and chief of kayak and the canoe team at the university. His research interests are genetics and performance, injury, and response to resistance training. So today he's going to be presenting on the RS671 polymorphism in the mitochondrial aldehyde dehydrogenase 2, which introduces an A allele that impairs ALDH2 activity and is unique to the Asian populations. He's shown recently that it is expressed in the skeletal muscle mitochondria, and that deficient ALDH2 deficient mice exhibit increased mitochondrial ROS emission. He will describe the association between the genotypes, athletic performance, muscle function, and muscle phenotypes in a Japanese cohort. Okay, please go ahead.
Thank you, Daniel. Good morning, everyone. I'm Naoki Kikuchi. I'd be glad to have the opportunity to speak this presentation. This is first time to speak in English virtually. My English is not good, but I believe my talk is very interesting for you. So please try to understand my talk. Today, I'd like to talk about association between performance and LDH2 polymorphism. First, let me introduce myself. I'm Naoki. I'm associate professor and strength coach in Nippon Sports Science University. This is my website. We have an English page and SNS account, Facebook, Twitter, Instagram, YouTube. So please check it. And I have been Vic University 2 or 3 years ago. And Sarah stayed for 3 months in Japan with Matt. However, Sarah cannot stay in Japan this year because of COVID-19. Our university, Nippon Sports Science University, is one of the famous universities of Japan. This is number of medals of Olympic Games in both summer and winter. We got 36 gold medal and 45 silver medal and 47 bronze medal. This is top in Japan. Our university is Tokyo in Japan here. Tokyo is big city. Have you been to Tokyo? This is called Rainbow Bridge and also Tokyo Tower. This one, small one. There are a lot of people in Tokyo, more than 900 million. So Tokyo has about twice the population of Melbourne. Next. Our study focuses on genetics and sports performance. And we have Japanese Human Athlon Project with my collaborator, Dr. Fuku, Dr. Miyamoto, Dr. Kumagai in Juntendo University, and Dr. Zenpo in Tokyo Sei University. We study the association between genetic factors and athletic performance, sports injury, and response to training. Today, I want to talk about elite performance and genetics, focus on ALDH2. ALDH2 RS671 is a specific genotype in East Asian, such as Japanese and Chinese. Previous study suggested that athletes has higher alcohol drinking frequency and quantity than non-athletes. In Japan, also we also feel athletes are drinker. How about in Australia? So why we have feeling that athlete has more drink alcohol than other? Why they can drink alcohol a lot? First, this study investigates the association between LDH2 genotype and drinking behavior. You can show Manhattan plot of genome-wide association study for alcohol drinking behavior. You can see LDH2 is strongly associated with drinking behavior. This is a frequency of LDH2 RS671, GG, GA, AA, male, female. This is no drinker. Higher frequency of AA genotype. Drinker, in drinker, GG genotype is higher frequency. So LDH2 RS671 polymorphism is strongly associated with alcohol drinking behavior. Next, what is the role of LDH2? If we drink alcohol, you will get aldehyde, this one. It is not good for health. LDH2 or LDH1 is necessary to metabolize aldehyde. And LDH2 RS671 is associated with LDH2 activities like this. GG have higher LDH activities, but AA genotype is lowest LDH activities. About 45% of people in East Asia have the inactive LDH2 genotype. In European, less than 1%. I don't know in Australia. So I'd like to talk about our LDH project. In this study, we have 3,055 subjects, 1,714 athletes, and 1,341 control subjects. Athletes divided into 3 groups: power sprint athletes such as weightlifting, wrestling, sprinter, and mixed athletes such as rugby, baseball, basketball, and endurance athletes. you can show frequency of AA genotype in LDA2. Y-axis is frequency of AA genotype in LDA2. This is controls and sprint power athletes, and mixed athletes, and endurance athletes. Frequency of AA genotype in athletes is lower than controls, especially in mixed athletes. So in mixed athletes, higher frequency of drinker, I think. Next, you can show results of grip strength in Japanese general populations. Y-axis is grip strength, and GG and GA and AA genotype. There is significant difference adjusted by sex and age. So our results suggested that subject with AA genotype has lower grip strength compared with GG and GA genotype. Next, you can show result of chair stand test in general population in Japanese. This test examines how many times can you do stand up from chair in 30 seconds. Y-axis is times of chair stand test, and GG and GA and AA genotype. There is significant difference also adjusted by sex and age. Subject with AA genotype has lower times of chair stand test compared with GG and GA genotype. This is same trend with grip strength. So AA genotype, no drinker genotype, is lower function than drinker genotype. Next one, I want to talk about knockout mouse study. We use climbing training model. You can show this picture. This one is climbing gauge. So they want to, when they want to drink water, they have to ride this wall. This is water. It is not beer, just water. We have 4 groups, 4 weeks of climbing training group in both knockout and wild type, and ground control in knockout and ground control. I will show you a result of grip strength and muscle weight and OHNE by Western blotting. This is result of strength and muscle weight. Left side, you can show grip strength. Y-axis is grip strength using this machine. And left one is wild type, ground control and climbing training. Right one is knockout, ground control and climbing training. And right side, this is muscle weight. Y-axis is muscle weight. Left one is wild type, and the right one is knockout type. So our results suggested that strength gain wild type is higher than knockout. Hypertrophy, this one, knockout is higher than wild type, but knockout has lower baseline muscle mass than wild type. And this is very important. Muscle quality is wild type is higher than knockout mass. So next one, this is oxidative stress for HNE. Y-axis is for HNE, and left one is control, and wild type and knockout. Black one is ground control, and white one is climbing training. Our results suggested that knockout mouse has higher oxidative stress in both resting and post-training. I think this is a main factor of difference training trainability. So summary, this is summary of our study. Frequency of AA genotype is lower in athletes than controls. AA genotype is no drinker genotype. Also, no drinker genotype, AA genotype, has lower grip strength and chair stand test. In knockout mouse, knockout mouse has lower trainability of muscle quality. And knockout mouse has higher oxidative stress, both resting and after training. So we think people who can't drink alcohol has lower trainability of muscle quality, and we can rescue using supplementation such as antioxidative, fish oil, or vitamin D. So now we are studying these topics in human. This is the last slide. LDH2 is associated many diseases, so associated with health. So we think LDH2 and response to exercise and training is good topics in the future, we think. So we are studying this one. Thank you for your attention. That's all.
Thank you, Naoki. I don't know what you're talking about. Your English is very good.
Thank you.
That was great. I'll just checking the chat now. Does anyone have any questions? Okay, I've got one here from Sarah. What tissues is ALDH2 expressed in? Is it muscle, liver?
Oh, liver is famous, but also in muscle.
Okay, great. I had a question. I was just wondering, do you have any idea of why people with the AA genotype have a lower grip strength? Is there any mechanisms as to why you think that might be?
This is a difficult question. I don't know.
I am sorry.
I don't know mechanism. I want to study mechanism of lower strength in maybe in all the populations.
Yeah.
Mm.
I've got another question here from Andrew, and he was wondering how many times a mouse climbs per day for the water.
So you mean how many times to climb to drink water?
Yes.
I'm sorry, we don't know because one gauge, they maybe three mouse, saying three mouse, three, how do you say, three mice.
Yeah. Yes, mice.
So,
yes.
how many times we don't know how many times each.
Yeah.
Mm-hmm.
Yes. Okay. Was there any other questions from anyone else? You can pop your hand up if you want to ask in person. No?
Can I ask one, Danielle?
Of course, please go ahead, Andrew.
Not a quick enough timer. So just on the climbing cage, did their water intake drop at all? Obviously, climbing up there is exhausting for the mice. So did they drink more or less than the controls?
So you mean how many drink for the control and climbing?
Yes, just total volume.
Almost same drinking and eating, almost same.
Okay.
It is answer for you?
Yes, thank you.
Okay, we've got one more question. We'll make this the last one. Have you replicated this data in any other populations of athletes or in response to exercise?
What do you mean?
So
not only in Japanese?
Yes, have you done it in another population, another Chinese or any other East Asian that is affected by this SNP?
We don't have plans and data.
Yeah. And what about in response to exercise in your Japanese cohort?
Mm-hmm.
Have you looked at whether your cohort respond differently to exercise if they have the AA or the genotype?
I'm sorry. I think AA gender type has lower tolerability of muscle quality,
yeah.
and we can rescue using supplementation such as fish oil.
Yeah. Okay.
And also there is the effect of drinking behavior. So also we investigate. We have to investigate.
Yeah. Okay, great. All right. Is there any last burning questions? Sarah? You're on mute, by the way.
Sorry, I put it in the chat.
Oh, sorry. You can ask it.
I was going to say, Naoki, I'm looking at skeletal muscle and response to training. And in my data, the ALDH2 gene changes with age and also with fitness.
Oh, really?
So do you have any, so do you have any ideas of how this enzyme changes with age when people get older? Do you know anything about it?
I don't know. But this is very interesting. Thank you for your suggestion.
Okay, well, we might stop it there. I'd like to thank Naoki for taking some time out of his day to present for us in unusual sort of presentation circumstances. I'd like to thank everyone for joining the first of hopefully many e-seminars. So thank you all and stay safe and social distance. And I will see you next time. Thank you.